This is a lecture video for two types of the problem in the transportation, logistics, and the distribution in the supply and operations management areas. And one of them is we apply a linear programming to solve the transportation problem. And we will apply the solver in Excel to find the optimal solution. And for the transportation problem, the transportation method here actually is a very special type of the linear programming. And we have the two common objectives, either to minimize the cost or to maximize the profits. And we considered for the cost or the profits for the shipping for the supplies to the customers. So this is what we have. The examples. So the U.S. pharmaceutical company has 4 factories. Those 4 factories supply the 4 major customers while delivering the cases, the drugs to the warehouses. And this is a minimal cost shipping schedule problem. This is the objective for this example is minimize the cost for the 4 factories to the 4 major customers. And all the information have been provided via the table here. So we have 4 factories, we have 4 warehouse, and the warehouse is like the 4 major customers here. And the 4 factories is the 4 supplies here, and for the Indianapolis it can supply 15 cases, and Phoenix can supply 6 cases. New York City, the capacity is 14 cases, the Atlanta has 11. While the demand in these 4 warehouses is 10 for Columbus, the 12 for St. Louis, 15 for Denver, and 9 for Los Angeles, respectively. And except for the capacity of the supplies and the demand for the customers, we also have the data information about the cost per case for 1 supply to 1 warehouse. So we have 16 price in total, because for the Indianapolis it could delivery instructs to Columbus, to St. Louis, or to Denver, to Los Angeles. So they have 4 choices for 1 supplier, and we have 4 suppliers, so we have 4 times 4, 16 possible choices. So this is all the information we obtain. And let's take a look with the tables here, the 25, 35, the 55, the numbers in these possible choices. Here are the price, and the button note here, the national note here stands for the demand for each customers, each warehouse. The Columbus needs 10, St. Louis needs 12, Denver needs 15, Los Angeles needs 9. And the last right column here stands for the capacity of the supplies. So Indianapolis has 15, Phoenix has 6, New York City has 14, and Atlanta has 11. And the total supply will be equal to the total demand. So how to solve this problem? Here we apply Excel, the solver in the Excel to find the decisions. So the optimal solution, the solution we like to find is how much Indianapolis need to deliver to Columbus. How many cases the Indianapolis need to deliver to St. Louis and need to deliver to Denver, to the Los Angeles. Also, how many cases for the Phoenix to deliver to the 4 warehouses here. So we want to know the numbers in this table. So this is the information we obtain. And the first thing we can have a shipping plan tables here. All of the cells I marked stands for the cells B13 here stands for the number of the cases the Indiana ponies delivered to the numbers. And the C13 here, the cell here, stands for the number of the cases the Indiana ponies delivered to the St. Louis. So the following stands for the different locations delivered to the different warehouses. And what we could do, we need to translate all the information here, and this is the cost calculation. So this table here stands for the cost. So how to translate the numbers here. At the very beginning, we have no idea about how many cases for one supply to one warehouse, but we can treat them as the variables we have in the linear programming. So they are the numbers we unknown. But we can use the unknown stuff here to stand for the cost for each of them. For example, for the cell B20 here, this cell here, we can use an equation like this is the number of the cases the Indiana ponies will deliver to the numbers. So B13 stands for the number of the cases, and if it times the 25, this is the price per case for Indiana ponies to numbers. So we use B13 times B16. This is the total cost of the total shipping cost if you deliver some cases for the Indiana ponies to the numbers. So this is the total shipping cost between Indiana ponies and numbers. And we can have another equations here equals the number, this is the number of the cases for the Phoenix to numbers, and times the price per case. For Phoenix to numbers, the price is 55, so we times 55 here, the B7 cells, and we will have the total cost. Why it is 0 right now? Because we do not have any numbers here to represent the number of cases. So it is 0 for each of the cells, so we have the 0 as the total cost. And our goals, our objective is to find the total, to minimize the total cost, and to find how many cases for each supplies to each location, to each warehouse. So we can continue to insert all of the information to use the formulas to stand for the total cost for one location to another location for the supply to the warehouse to the customers. So for the B22 here, it stands for the total cost between the New York City to numbers. So we have equal to the number of cases times the price. Then we can have all the information, all the equations which represent the total cost for one supplies to the customers. We just insert all the information here. And what is the total cost? So the total cost will be, if you take a look at the equation here, the total cost will be a summarization for all of the cost for one location to another location. So we just sum all the cost here, and then we will have the total cost. So this is the total cost. And what we need to do here, we need to analyze the total shipped and the total supplied. If we know the Indiana ponies how many cases the Indianapolis delivered to the Columbus, to the St. Louis, to Denver, to Los Angeles, we will know the number of total shipped. So we still use the sum equation here to stand for the number of cases the Indianapolis ships. And we can still have other total shipped for the Phoenix, for the New York City, and for the Atlanta. So they are the sum for all the number of cases it has been shipped. And for the total supplied, we still use the sum, but sum the columns here. So we sum the B13 to the B16. B13 is the number of cases the Indianapolis delivered to Columbus, and the B14 here is the number of cases for the Phoenix delivered to the Columbus, and this is the New York City delivered to the Columbus, the number of cases, and this is Atlanta delivered to the Columbus. So we sum all the numbers here. The number here, the B70 here, stands for the total number of the cases the Columbus received. So this is the total number of the cases, the supply cases. And we can have other three here. So this stands for the total supplied for the St. Louis, and this stands for the total reply for the Denver, and the total reply for the Los Angeles. So we have inserted all the information here. And what we need to do the next step, after we translate the information, the formulas into the Excel. The next step is translate the model, the information we have inserted here, into the solver, because we use a solver to solve the linear program here. And the solver should, under the data models here, if you don't find any solver here, you can add the solver via click the file and click the options and click the add-in here, and we have the Excel add-ins. Click go and just check the solver add-in box and click OK. And you will be able to find a solver in Excel. And this is the tools help us to solve the linear program in the linear model. So the next step, we need to connect the solver and insert the model into the solver to find the answers. Once we connect the solver here, you will be able to find they have the different information you need to insert. The first one is about the objective, and this is the variables, and this is the constraints. So this is the three main things for any linear programming. The objective for this problem, actually we want to minimize. So we have three choices: maximize, minimize, or a specific value. So if you choose the specific value, which means your objective is the specific numbers, so you can insert your numbers here. But for this problem, we wanted to minimize the cost, and the cost we have used one cell, the cell F25, to represent the total cost we want to minimize. So note here, for any problem you want to use solver to solve the linear program via Excel, the first thing you need to do is translate your linear model into the Excel. So you need to have a one cell, an individual cell to stand for your objective functions, and you need to have cell to stand for your variables. If you have two decision variables, then use two separate cells to stand for these two decision variables. If you have 10, use 10 cells. For this problem, actually we have 16 decision variables here. So because we do not have any idea about how many what is the number of the cases for one location to another locations. So we have 16 decision variables here, and we use one cell for any linear programming model in Excel. You need to use one cell to represent your objective functions. So here is our objective functions, the total cost, and we choose F25 as the cell to stand for the objective functions. And then we need to choose the changing variables, the decision variables we have. The decision variables for this specific problem is all the cells we have, the 16 cells. The cells here stands for the number of cases for one supply to the one customer respectively. So we have those 16. And what kinds of constraints we have for this problem? We have the total supply, we have the total shipped, we know the capacity for each supplier, and we know the demand for each customers. So one of the constraints we may have is the total shipped. The total ship here is how many Indiana ponies has been shipped to this fall. So this is the total shipped. The F13 here stands for the total ship cases for Indiana ponies, and we know the capacity for Indiana ponies is 15, which means what the Indiana ponies has shipped cannot exceed what it has. So the Indiana ponies only has 15. So what is the total shipped for the Indiana ponies should less or equal to 15. So this is one of the constraints. But because of the total ships here for each suppliers, they have the same the constraints. So actually we can choose for the F13 to F16, which stands for the total ship for the Indiana ponies, for the Phoenix, for New York City, for the Atlanta respectively. All of these four cells should be less or equal to. Actually we have different choices here, but for these constraints we make them less than or equal to the F6 to F9. So F6 stands for the capacity of Indiana ponies, and F7 stands for the capacity of the Phoenix. So we have all the asterisks here, and if all the countries we have involved here, we just click OK and back to the solver window. If we want to add more countries here, so we just need to click Add. And for this problem, we have another constraint of the demand. The B17 here stands for the total supply. So this is the total numbers, the total cases for numbers the numbers has received. So what it has received should be equal to the demand. So it need to equal to the numbers here for the numbers demand. And because the other three total supply here has the same constraint, so we can just pick all of the three, and they should be equal to the total demand here. And we do not have other constraints, so we click OK. And another thing we need to check is check this box. Check this box stands for all of the variables are non-negative, which means positive. And we need to choose the simplex LP. This stands for this is a linear programming model, not nonlinear programming model or others. This is the linear programming models. So we just need to check the simplex LP. And after that, just click Solve, and you will be able to see the another windows here. This is give you like if you prefer to have the reports for the answer report, or a sensitivity report, or a limits report. You just need to check them. If you don't need that, you just do not check. And the reports here give you like they find your numbers, and just click OK, and then you will be able to have the numbers. So the result here stands for, if you want to minimize the cost, and the minimum cost will be 1,835. This is the total cost. And what is your choices? You need to choose to delivery 15 cases for Indianapolis to Denver, and you may need to delivery 6 cases for Phoenix to Los Angeles, and delivery 10 for New York City to Columbus, and another 4 because we know the New York City have 14 cases, so you still have 4 cases, and those 4 cases should be delivered to the St. Louis. And Atlanta deliver 8 to St. Louis and 3 to Los Angeles. These decisions, these choices here will satisfy the capacity constraints, also the demand constraints. So this is how we use the solver in the Excel to find the linear programming. And what I want to introduce the last in sum, the first thing you actually need is to construct your linear model. Illustrate the objective function, illustrate all the constraints you have, illustrate the decision variables, and after you have the linear model, then translate your linear model into the Excel. Use one separate cell to only one cell to denote your objective function. Translate the equations into the cell, and use the separate cell to stand for the decision variables depending on how many decision variables you have, and translate all the constraints here, and then use solver. You translate the model into the solver, and then you will be able to find the result. So this is the first types of the questions I'd like to introduce, the transportation method via linear programming. And another method which is called Centroid method. This is use this method to locate one location which has the closest distance among the suppliers and the customers. And the information you need to have is the distance between the facilities and the value of the goods it need to be shipped between the two facilities. And we have two suggestions, like the inbound and outbound transportation are equal, and even though you do not have a full note, the no special shipping cost for less than a full note. So this is the suggestions here. And how to use this Centroid method? Actually, we have these two formulas. The one of the formulas stands for the horizontal direction, and another stands for the vertical direction. So the basic idea is like we translate the locations into a x1 coordinate. So we have the number, the number for x coordinate and the number for y coordinate for each location. For example, this is what we have. So for each location, we put the locations into a coordinate, the figures here, and we have the numbers for each locations, the x value and the y value, and it according to the real situation you have, the real distance we just put the location into a xy coordinate. And if we want to use the central method formulas, actually we want to find a location, a central location which has the closest cost, the closest distance among all the locations here. So we have two formulas to calculate for the x value and the central y value. So for the x, we need to sum all the distance times the demand. The V here stands for the value of the goods, so the number of the goods moved to for the I location. And the small dix stands for the x coordinate of the I location. So it depends on what is the location here. The I stands for the location, and the small diy stands for the y coordinate of the I location. So this is the different values for the locations. For example, this is the a small diy for this. For the I here stands for the different locations. So this is the 1,000 acres, and this is its x value. This is the 450 is the y value. And let's take a look at the example here. The company needs to locate an intermediate holding facility between its refining plant in Long Beach and its major distributors. So actually we have this is the plant, the refining plant, and distributors, and it want to find a location, a central location, which has the smallest distance, the smallest cost, further smallest cost, the lowest cost. So we have all of the information here, and this is the Long Beach location with the x value and the y value and the volume of the demand. So all of the V stands for the value of the goods move from one location to another. And this is the volumes. Like for the Long Beach, it has 1,500. This is the plant, and the distribution center 250 will deliver to the Anaheim, and 450 will be delivered to this location and all others here. And how to find the numbers here? So for the objective location, for the central location we want to find, we also need the two values to locate the location into the x1 coordinate. So we still need the x value and the y value. How to calculate the x value for the objective function? We need to find, way back here. So this is all the value for each of the location. It may need to distribute times the number of the volumes. So here 1,500 is for the Long Beach, and this is the Long Beach is the x value. So we use 325 times 1,500, and for this location the x value would be 400, and the value, the value of goods will be 250. So we have 400 times 250, and so on and so on for other three locations. We just use the x value times the value of the goods. So 450 times 450. 450 times 450, and 350 times 350, and 25 times 450. We just sum all the numbers here, and this is the total value of the goods. So 1,500 for Long Beach, and 250, 450, another 650 and the 450, and we obtain a number which is 307.9. This is the X value for the objective location we prefer to find for the central location. And the same, we can find the Y value. For the Y value, we just like change the X value with the Y value, and we still use the Y value times the value of the goods. So we still use the Y value times the value of the value of goods, and the same way, and then we find the Y value for the central location, which is 216.7. And this is after rounded with the integer. So this is the central location we are finding. So this is the locations the company need to consider to locate as its distributors. So this is how we use the centered method to find a location which has the lowest distance for the plants and the customers, and the further lowest cost. So this is the centered examples, and this is the two types of problems I'd like to introduce for the topic of location, distribution, and transportation.